So, day 5, final day. It's crazy. This week has gone by so fast. Just make sure that you can see me, hear me. You got your workbook in front of you. You got a pen or pencil, and you have your parent nearby. Make sure that's all good. Got one more name to fix really quickly. Okay. Checking one last time. So the names, so they're all good. Got one more fix. Okay. Okay, all the names are fixed. So again, workbook, pen or pencil, parents nearby. You can hear me, you can see me. So again, if you guys don't know already, the reason I'm doing this camp is because I want to empower younger girls to become future woman engineers through a camp with fun activities, role models, and to bust the stereotype. So yeah, throughout the week, I've given you guys role models to look up to, fun activities to go over, and different information for each of the engineering, so you know what's coming up with the different engineering. So that's the reason I'm doing this camp, this 5-day camp for you guys for 4th to 8th grade girls. So today's t-shirt, since there's not a specific topic for today, I decided to just have a STEMinist shirt. I thought it looked pretty cool. So here's today's shirt. So since today's not a specific engineering, it's electrical engineering day plus more. We're going over electrical engineering because it's one of the core 4 engineerings. So again, if you guys don't know already, Caroline is our chat moderator and prize patrol. She is a senior in high school and in her final year of Girl Scouts. She's also currently working on her Girl Scout Gold Award, where she also hopes to inspire middle schoolers to explore a future in journalism. Her project is called Youth in Journalism, and she hopes to be a doctor. So she's a STEM girl with a little bit of STEAM thrown in. So I'm going to show you guys the slideshow of all the challenges and activities that you guys have posted throughout the week. So let me pull that up really quick. No, this camp is not only for Girl Scouts. We just have a bunch of Girl Scouts helping because yeah, I've been asking around and a bunch of Girl Scouts decided to help me, but it's not only for Girl Scouts. Okay. Okay, so here's this week's challenge slideshows. So we've got 2 different engineer drawings from the beginning of the week. This one's got their safety glasses on and a NASA hat. That looks pretty cool. And we got someone with a love t-shirt and her safety glasses too. Then we've got this baking soda and vinegar volcano from the beginning of the week. I liked all the colors in that one. We've also got this very long strand of strawberry DNA. We've also got this smaller strand of strawberry DNA, but this one still looks just as gooey as the last one. Then we've got this, I'm guessing that's the elephant toothpaste. All of the elephant toothpaste, they come out slowly, but they just keep on coming. You don't know when it's going to stop coming out. And then there's this strawberry DNA, also very large strand. Then we've got this elephant toothpaste or baking soda and vinegar volcano from day 1. We've got this one. This one's a very dark strand of DNA, a lot of food coloring added in. It's cool how the food coloring stuck to the DNA when it came apart. And then we've got this one. This is Mara G's strawberry DNA strand, as she's looking at the video from day 1. This is a toppled over experiment from day 1. And this is them pouring in the catalyst, which is the yeast. And that's it falling over again from a different angle. Here's another strawberry DNA strand. Then we've got in the making and the finishing of a catapult from day 2. We've got another catapult, very colorful. And here's another angle of that. And here's her in her safety glasses watching the camp. And here's an up close of the colorful catapult. And then a setup of the materials for the catapult. Here is a dog food launching catapult with a cute little button on the side. Then we've got a catapult in the making. I think that one was posted during camp that day, which is kind of cool. Then we've got the cute little setup for mechanical engineering day 2. And I can see she has her bowl of ice water by her with the hot glue gun. And her safety glasses are nearby. That looks cool. And then here is her final product of her catapult after adding a bunch of different improvements, like how she bumped up the where the spoon was, and how she added more rubber bands in certain spots and more supports, I see. And here's all of the different types of catapults they made. Her and her brother. Her brother wanted to join in. And then here's her grabber from Mechanical Engineering Day. She has some issues getting the straw and the popsicle sticks to get together, but she improvised and used stacks of popsicle sticks to put into the large straws, and she used some duct tape, I see. This is another catapult with cotton balls and the robotic arm. And here's another catapult where it has a ammo holder where it holds the marshmallows. Here's a colorful one with some, it has some storage for the cotton balls, and it's got some gems on it and a holder for your finger for pulling back the spoon. And then here is for day 3, the start of day 3, we've got a few paper airplanes and the launcher already made. And here's another view of that. And then here's in the making of one of the paper airplanes during the live step-by-step. And then here's another in the making. Here's in action of one of them launching their origami rocket. And then here's Emily Airlines airplane. That's what she named her company for, if she makes airplanes. Here's another angle, the blue with the blue rubber band and the blue laptop and the blue paper airplane. Guessing her favorite color is blue. Here's another angle of that. Cute drawing on the paper airplane. I love it. Here's a mobile catapult. I think, does the spoon have a smiley face on it? I didn't notice that from before. And then here, so this isn't the bridge we originally decided to make, but this is so cool. It's like a walking bridge, like one of those bridges you'd have over the water where you could view the water. It's very pretty. I love it. And then here is a toothpick pyramid, more of a pyramid than a tower, but it looks very precise. And here's a jumbo one in the making. I don't think we got the finished product of that one, but seeing this, I think that was her favorite day. A lot of toothpicks and marshmallows that went into that. And here's another in the making of it. Very concentrated. And then here, I'm guessing this is from the live step-by-step with trying out the different shapes, seeing which one is strongest to build up with your tower. Here's her watching the camp. So here is her attempt at the toothpick tower, and the next one is her mom's attempt. So they had a lot of fun figuring out stability and supports for this one. Here's someone else's pyramid. Looks more, well, toothpick pyramid, more of a tower. Then we've got a popsicle stick bridge. Love the shirt. Love FC Barcelona. I have one myself. And then this is someone else's toothpick tower. That one's really, really tall. Here's another angle. It went out sideways a bit. And then here's another angle. So that is the end of the slideshow. Let's get into some review on the Core 4. So the Core 4 plus more. So throughout the week, stuff we've gone over. So we've got the core four engineerings: civil, mechanical, chemical, and electrical. Yeah, they're the core four like topics or categories of engineering. And then from those four, there's a bunch that branch off of them. So on the next slide, I'll show you some examples. So on here, let me make it a little bigger for me. Okay, so there's these core four: civil, mechanical, chemical, and electrical. And from those four, all of the other engineerings branch off of them. For example, with mechanical, aerospace and aeronautical branch off of it because they're also working with like the ideas of mechanical, but they're more focused on like aircrafts and flying in the air or outside or inside the atmosphere. And again, another example is robotics, which also branches off of mechanical because they focus on the same things as mechanical, but they're focused more on robotics. Same with wind, thermal, automotive, acoustical, power plant, agricultural. Those are different types of engineering that branch off of mechanical. Those aren't all of them, but those are a few of them. With civil, some of them focus more on traffic, some of them focus more on building things in the ocean, like some of those bridges that, like those underwater tunnels that your car drives through. Mine drives through those on the way to the beach every year. There's also highways, environmental, solar, coastal, earthquake. Those are different examples of civil, ones that branch off of civil. Again, those are all civil engineering, but they branch off and they're more, what's it called? They specialize on those types of topics, but they still are in civil engineering. With chemical, they've got polymers, biomedical, cellular, food, materials, paper, petroleum, pharmaceutical, which is pharmacies and medicine. Electrical, it's got the certain ones that some that branch off of it are computer, hardware, information technology, network, optical, power, telecom, which is telecommunication, and electronics. Those aren't all of them, but those are some of them. Those are just some examples. But again, these are the core four that every other engineering branches off of those four topics. And then there's also some engineerings that share from two of them, which I think we're going over one of them later. But those are the core four. On to the next one. So these are some of the words that we went over for engineering. Some of them are, so math, science, technology, engineering. STEM, again, how engineering is a part of STEM while also using STEM. So then there's also problem solving, inventors, solutions, and those are just some of the keywords. Oh, UJ says my mom's in telecom. That's really cool. I didn't know that. So she branches off of electrical engineering. So these are the words for engineering. And these are just some of them, but there's many other things like create, build, every day, everywhere, everyone. Like if you look around your room, lots of these stuffs have been made by engineers. Like, let me think. Well, so my pen right here, the ink was most likely helped being made by chemical engineers who found a certain type of ink that would dry really fast to not bleed on your hand, but also have a vibrant color. So a chemical engineer helped to make that. And the chemical engineer would also maybe help to make hand sanitizer and stuff like that. But if you look around your room, it's a bunch of stuff that engineers have made. So on to the words for chemical engineering that we went over also on Monday. We've got processes, reactions, chemicals, raw materials, products, manufacturing, optimization. So processes in chemical engineering, it's where they are tasks that change substance for a purpose. Like they change something so that it's not just a material, but now it has a purpose. Like they get raw materials, which is like the basic material used to make a product, like wood or trees is a raw material, or metal is a raw material. But they grab those raw materials and put them together to make products, which are finished items after chemical reactions. Optimization, it's where you make a product be the best, improve to find the best values, like be the best it can be. So optimizing it is making it the best it can be. So those are a few different keywords for chemical engineering, but there's many more, like fuels, healthcare, paper, foods. Those are different things that chemical engineers help to make. For mechanical engineering, some of the keywords are machines, movement, power using and power producing machines. Power using machines include like refrigerators or air conditioning. They use power to work. And power producing machines, they produce power. Like a generator, it makes power. So it creates power so it can power your house. Or an engine, it generates power to keep your car moving. While like power using is like refrigerators and air conditioning. They use power to work, and power producing, it produces power to power other things. And hydraulics and gears, those are used within machines. Like there's gears, cranks, levers, many other things that like belts too, like conveyor belts and stuff like that, that are put into, they're used together to create machines like a assembly line or an engine. It has all these moving gears and belts and all that inside of it. It's this whole big mechanism made out of hydraulics, gears, etc. So that's the keywords for mechanical engineering that we went over. So now we're on to aeronautical and aerospace engineering. This branches off of mechanical. So it uses mechanical while also focusing more on the topic of like aircrafts and space travel and flying in and out of the atmosphere. But it's got thrust, weight, drag, and lift. Thrust helps to move the aircraft forward or up. Like if it's a jet, it's moving it forward. If it's a spaceship or a rocket ship, it's thrusting it up to go into space. Drag is from either gravity, when a rocket is trying to go up, but gravity is dragging it back down. That's drag for rockets. Or drag is pulling the jet backwards because of wind resistance. The wind is pushing at it, so it's dragging it back a little bit. But thrust comes in to either move it forward or up. We've also got weight, which is it's always there, whether it's moving or not. With weight like ties in with gravity. Gravity is always pulling it down, so weight is another one of the forces. And then there's lift. So the wings on a plane or a spaceship, those wings are built specifically so when the air flows over it and under it, it creates a force of lifting up the plane because of the way the air pushes it. So that is lift with the wings. So there's lift, drag, and thrust that happen only when the aircraft is moving. And then there's weight that happens all the time, no matter when it's moving or not. Weight is always there because there's always gravity. There's also stability, where you control, like keep the speed, direction, altitude in control. It's stable while it's moving in the direction it needs to be going. So controlling the speed, direction, altitude. So there's rockets and jets. They're just one example of each of them. So rockets are more in the area of aerospace, where they travel into space where there's no oxygen. So they use stored oxidizers to propel the aircraft. So since there's no air in space, they have to bring it along with them. So they grab it and bring it with them so that they can burn their fuel in space with the air that they have with them, since it's not already there. With jets, they're in the atmosphere with the air, so they don't need oxygen. It's already there, supplied for them. But with rockets, it's not there, so they bring it with them. But with jets, they use air outside of the aircraft to propel the aircraft. And then, stability is controlling the speed, direction, altitude. But so aeronautical focuses on only things that are in the atmosphere, while aerospace focuses on things in and out. So there's aerospace, and then aeronautical is a part of aerospace. When you're an aerospace engineer, you can choose to focus more on aeronautical or on astronautical, which is going into space, or you can just focus on all of it and be an aerospace engineer. But aeronautical, only in the atmosphere, and aerospace is both in and out of the atmosphere. So that is aeronautical and aerospace engineering keywords. There's also civil engineering keywords that we went over yesterday with roads, buildings, and bridges, which are just a few examples of what civil engineers can build. There's also the word surveying, where they survey the land and water nearby to make sure that the water is drinkable or usable, and the land is able to be built on top of. Like, say the land is like the soil is very like, what's the word for it? If the soil isn't good enough for building on top of it, it may end up making your building sink into the ground. So they need to survey the land to make sure that the building won't sink in over time or start to tilt over time because the land is uneven or anything. So they need to survey the land before they construct on it to make sure the land is good enough for what they're building. There's also concrete and steel. Those are different types of things that are used in building. They're different materials to be used in civil engineering with building buildings, bridges, roads, anything. There's also beams and cables and different other stuff that is within civil engineering, but the main things that they build or use, these are the keywords that we went over yesterday. But there's also that branches off of civil engineering. There's like transportation, which focuses on roads and bridges. There's also different types. There's like construction management, which are the people who like watch over the construction, but there's different things that branch off of civil engineering other than civil engineering being like the engineering. It's the core force, so there's many other topics that branch off of it, and these are some of the key words that go with that. So also the engineering process that we've gone over throughout the week every day. We identify the problem and explore different possibilities and designs that we can use, and then we go into the trial and error cycle of designing, creating it, trying it out, and if it needs improvement, you do the cycle over again, redesign, recreate, try it out again. If it needs improvement, you do it again. So the trial and error cycle is separated from identifying the problem and exploring, because once you do the exploring and knowing what your problem is, then you can start doing trial and error until you get what you want, and then you build the real thing. So that is the engineering process. And remember, again, it's okay to fail. It's okay if you don't get it on your first try. It's normal. You don't always get things on your first try, because if you get on your first try, there's no room for learning or getting to know more. Like, if I didn't get something good on my first try, then I can improve it, do better, learn from the situation, and be able to do better on my next build or next experiment or next this, next that. So again, it's okay to fail. It's your first attempt in learning, or second or third or fourth, but it's okay to fail. You just have more room to improve it and make it a better product or a better building or a better anything. But yeah, this is the engineering process. So today is electrical engineering and more. Again, we're going over electrical engineering with the definition because we've got to get through all the core 4. So we're doing that and then going into a Q&A session. So that's why it's electrical and more. So since it's electrical engineering, we're going to go over that. Next slide. Electrical engineering and other engineering fields, day 5. So pull out your pencils or your workbook. If you don't have the workbook in front of you, you can just follow along, and the answers will be on the Facebook group. Again, if you're not on the Facebook group, you can have your parents email me. So electrical engineers solve problems using their knowledge of electricity, electronics, electromagnetism, and electromagnetism, to develop solutions. So again, electrical engineers solve problems using their knowledge of electricity, electronics, and electromagnetism to develop solutions. Okay, so on to the next one. Electrical engineers design solutions for anything that plugs in, uses a battery, contains a motor, has a microprocessor, or uses radio waves. A few examples of things that use radio waves are cell phones and Bluetooth, etc. And then electrical engineers design from very small to very large systems. They design microchips that fit on the head of a pin to the large grids of power that flow through large communities and cities and communities. Electrical engineers design and program systems using coding, circuits, magnets, conductors, coils, switches, resistors, capacitors, inductors, transistors, and semiconductors. So this is the page. Let's click to the next page so you can see the words filled in. So let me go over a few of the words. So electricity is energy that can build up in one place to flow from one place to another. Like it's energy that can power other things, electricity. Electronics, it's a branch of physics that deals with emission, behavior, and effects of electrons. And electromagnetism is a type of magnetism that's produced by electric current. Yeah, you can use electricity to create a magnet. That's really cool. Also, a microprocessor, it's a computer processor that contains an integrated circuit chip containing millions of very small components, including transistors, resistors, diodes, and diodes that work together. Also, radio waves are electromagnetic waves used in radio, television, or radar communication. And coding is a method of giving a computer instructions to perform a specific task. So you're just kind of, coding is used to program things. And a circuit is a complete path around which electricity can flow. These are, yeah, as it's written down, a lot of big words, but this is just kind of a basic definition of electrical engineering. So is everybody, okay, we've got a hand raised, so we'll give it a second for them to fill it in. If you haven't finished filling it in, raise your hand, and when you're done, lower it and we can move on to the next thing. By the way, Cassidy S likes computers and engineering. So this is your day. We are and will be talking to an electrical engineer with a lot of coding experience. So that's really cool. Still one more hand raised. Yeah, again, these are a lot of big words. So it's just kind of a definition of what engineering is like. If you don't know the big words yet, but you're interested in electrical engineering, you'll learn more about what they each mean. But so the hand is down, so we can move on to the next thing. So I want to introduce you to Abigail Mixon. She is an electrical engineer, and so yeah, she's an electrical engineer we're about to talk to. She's a senior in electrical engineering at Florida State University. She started her studies in chemical engineering and later shifted into electrical engineering after she took a general engineering class in her freshman year, filled with a lot of guest speakers from different fields in engineering. She was inspired by an electrical engineering speaker, and she's also a lifetime Girl Scout. So she can chat with you guys about her experience, and if she wants to add anything more onto a basic definition of electrical engineering. But here is Abigail.
Here I am. Hello. Yeah, so like Ruby said, my name is Abby or Abigail Mixon. I go to Florida State in Tallahassee, and I'm an electrical engineering major. I'm a senior, so I'm almost done. I'm about to graduate. Very close, very close. It's been a long time, but we're almost done. So basically, I wanted to be a chemical engineer, and because I was just like Ruby, I was super excited about like all those chemical reactions and the different experiments. And like Ruby said, I loved cooking and stuff like that. But then I took a class with a bunch of other students, and we learned about all of the different types of types of engineering like you guys are right now. And we got to talk to a lot of professors and other people that were engineers. And there was somebody that came and spoke to our class, and he was telling us about a student who was an electrical engineer major who also studied music, and he ended up working for a company to develop music. Like he engineered all kinds of stuff for music and stages and live music and like your headphones and all kinds of stuff, the speakers that come out of your TV. And I was like, that's awesome, because I really like music. I used to play the cello. I really like EDM music, if you guys know what that is. And I just was really excited about that. So right after that, I went down to the office and I changed my major, and I was like, this is what I want to do. It's so fun. But like Ruby, some of your keywords, you guys are learning about, you kind of learned about a microprocessor. If you want to see what that looks like, this is a microprocessor. It's super small. This is the kind of thing that would be in your phone. I'm not gonna, it's kind of exciting. There's lots of things in there, lots of stuff going on, but that's what this looks like. And then this is also a microprocessor. So this one has like a little joystick, like if it was like a gaming system, and this thing will light up. I'm not gonna plug it in because it'll mess up my camera and everything. But that's what those look like. So those are more like computers. They deal with, you can plug those into your computer, and that's more of like the coding side. So there's lots of different coding languages that I get to learn, and we basically get to program the computer by giving it instructions and telling it exactly what to do. One of my favorite projects we ever did was we plugged this into our computer, and we got to learn a coding language, and we basically instructed the computer on how to turn the lights on. And the lights, we got to control how fast the lights went and what colors they turned, and it was super cool. And then another one of your keywords is circuit. So you guys know like the power lines all around the city and those big boxes behind buildings that are like, those are called what are they called, transistors and stuff. They are like big circuits like around your entire city. So then in classes and stuff, you get to learn about tiny little circuits. And so this is called a breadboard. It's not bread, it's a little piece of plastic, but you get to plug this into a power source or your computer, or you can plug it in to get a source of electricity. And you use things like this. These are going to be conductors. These are all different sources or things that you would add into your circuit. These are little capacitors. This is a huge capacitor. And you use these little rainbow cords. They look really cool. They look like a rainbow. And you connect them all into a circle, and that system does all kinds of stuff. And it gets to power your phone. It can power the entire city. It can power your car, your TV, anything that plugs in or makes light. That's what we deal with. And it's all these little tiny systems These nails do not help me at all. I need to take them off. But working with all these little tiny things to make all your stuff work. It's really exciting. It's like a big puzzle. It's a lot of math, but it's really fun. And sometimes when I'm coding, I feel like a hacker, like in the movies. It's a really good time.
That sounds really interesting. Like feeling like you're a hacker or
Yeah.
like doing a little puzzle. I think that's really interesting. And if you guys like working with tiny little things, then this is the engineering for you. Or if you think it's cool how you can program something to like do a activity or do a just like to program things. If you like programming things or doing coding, then this is also an engineering for you. But thank you for talking about engineering. It was really cool with the little show and tell of your stuff.
Yeah.
Yeah, I recently just upgraded my computer. One sec. And I have a few things for show and tell for electrical engineering. I don't know what this is. If you know what it is, then let them know. But I just pulled this out of my computer. Disk drive, something electrical engineering.
Hard drive and you put it in the computer and it probably has stuff on it that or programs on it.
Yeah, it's something. And then this is I think the RAM or
Yeah, so RAM, I don't remember exactly what it stands for. It's random access memory, but it's basically that right there tells the computer how to like remember stuff. So you can
That's really cool.
literally give a computer memory. It's crazy.
So what is it? Could you just how do I have a question for you. Describe your thought when like, you realize that all electrical things run through a complete circuit. It's like a through the cities of electrical power lines and stuff. I remember
Well,
hearing
yeah,
that.
so when you first start learning about circuits and everything, I have some of my like drawings, but you draw little tiny circuits. So like right there, that right there is a circuit. So like this would be like a power source. This is a resistor, and it goes through this circle. And when you're learning how to do all this, you draw all these little tiny circuits and you do all the little puzzles and stuff, and you're like, okay, and then you build it on here. But then one day I looked outside and I looked at the power lines, and I think somebody told me, oh, like that power line is like that's the resistor that you like draw on your little circuit. And I was like, that's huge. That huge thing is a resistor. That's these little things. And they're like, yeah. So I was like, that's so cool that these and like these little circuits that I'm learning how to deal with are really just they power your entire city. They're everywhere. There are these huge things that people have to get on ladders to work on and put together. And I just love how hands-on the entire thing is.
So they can be from the tiniest little thing on the end of a
Tiny
pin
little things. Yeah,
or
like
to this big thing that's throughout your entire
you
city.
can even read some of that stuff.
Is that a
And
little mini computer?
yeah, this is the microprocessor that you were talking about,
That's so cool.
right? This little box in the middle, that's the entire computer. That's the entire computer. And then everything else is either like a button or a switch or like a little writing saying this is what this is. But the entire computer is that little box in the middle.
That's crazy.
So that's like what's in your phone and stuff.
It's crazy how I remember the first computer took up an entire room, and now it can fit into this little tiny
That's
box
tiny.
thing. Yeah, I don't get how that works. It's so crazy. We've got a question. Have you gotten into like having a job yet or anything? But what, if not, then what do you do in a normal day?
I haven't started that process yet, just because COVID and everything, and but I have friends that have done that, and some of them, I have some friends that have had internships in like a magnetic lab. I'm not exactly sure what they do, but I'm pretty sure it's like the world's largest magnetic lab or something, and they have these huge magnets that fill these rooms, and it's down the street from me, I think.
That's
But they
cool.
go there and they work on the magnets and stuff, and they learn how all that works. And then I have some friends that work at it's called like the power, something about like the Tallahassee power systems, and they go and like work with the city and learn how like the city power system works and how the electricity is distributed throughout the city. So they work with that kind of stuff, which is really cool. It can really be anything.
Yeah.
I have
So you.
friends that just sit and code at their computer all day.
Mm. Someone else asked, where are you planning to work after you graduate?
There are so many options. I have been looking around. You guys know what Teslas are? Those fancy cars. I was thinking about that, maybe like looking into working with Tesla, which would be super cool. But I also really love concerts and music festivals. And like when I was a kid, I was obsessed with like Christmas light shows and stuff. So I feel like maybe I could see myself like designing light shows or something like that. Or like I remember when I was a kid, they had like laser shows all the time with like music that would come to school and stuff. And I just love that. I was like, I want to design that.
It's so cool how you went to that like engineering fair and found out that this engineering fits better because it links with music and
Yeah,
art.
it felt close to home. Like I grew up playing music and being obsessed with like going to concerts and stuff. And so I actually am passionate about this stuff because it's every time I get the light to turn on my little device, I get so excited.
That's so cool. It's cool how you can work from either the tiniest things to the largest things throughout a city. Another question we have is, have you ever tried to make anything from electricity after knowing how to do it?
Yes. I took a lab at school last year before we got sent home for like the pandemic and everything. And I had a lab partner, and he thought he was smarter than me. And he tried to take everything over, and he was just putting little things in here. He did not know what he was doing. And it started smoking and it started to light on fire because he had plugged it into the computer and turned it on, but it was completely wrong. And so I think he touched it and he like burned himself or something. And I was like, dude, you can't plug it in yet. Like you can't plug it into the electricity before you even set up the circuit. It's gonna light on fire. It was terrifying.
Well, does anybody else have any more questions for Abigail before we move on? Give you a few moments to give your final questions. Yeah, again, how Abigail went through that experience of changing engineering. Just know that if you aren't like, if you, I did one in the Q&A. Oh yeah, someone earlier said that your purses in the back made a smiley face or made a face. But I'm guessing she really likes your purses. What's the coolest thing you've done so far within your recent career of electrical engineering?
I think when I first learned a coding language, I and I got and I programmed my computer. I told it what I wanted it to do. I typed it all out, and then I plugged it into this thing. And so there's little lights, there's red lights and green lights on the bottom over here. And I got it to turn on at like different frequencies and different speeds. And I got to control which color turned on and how fast it got to go. And I got it blinking really fast. And I was like, this looks like a strobe light. So,
Yeah, it's really cool. I there's like certain people I saw on social media that this guy got a normal LED strip light set, string
yes.
light, and he like programmed it to do many different designs and stuff. And
Yeah, I want to learn how to do that
that'd be
because
so
I have
cool.
some LED lights on my room and I want to make them do rainbow colors.
Well, if you ever
Oh,
figure that out, let me know because I've got a set
I
in my
will.
closet that I gotta put up.
Of
But
course.
what would you suggest if what, what would you suggest to someone if they wanted to learn more about electrical engineering or
I
like go
would,
into it?
I mean, I would just start. I definitely think like you do need a little bit of a physics background. So maybe in high school, if you wanted to try taking like a physics class and just, I mean, electrical engineering really does incorporate almost all of the STEM components. Like I had to take physics classes, I had to take chemistry classes, I had to take computer classes, all the math classes. So like don't give up. If the math is really hard, you do have, like Ruby said, like if you fail, that's it. That is your first attempt in learning. Like it, it's all kinds of hard stuff, but you got to just keep trying.
And you can make it.
Yeah, you will.
Well, thank you for talking with us about electrical engineering. It was really cool how you can program things, set things up, have a miniature computer that fits in the palm of your hand. It's all so cool. But thanks for chatting with us and giving us a little inspiration for keeping going to get into engineering. Oh, one more thing. What is your favorite thing as an electrical engineer?
I think my favorite thing is the fact that I get to work with my hands. Like, look at this whole bag of stuff that I got. I got all these little tiny resistors and stuff, and I like to, you can go through and make different kind of circuits and different kind of little puzzles and figure it all out. It's like putting together like a little art project almost. It's really cool. It's like putting together a puzzle, but it's all rainbow and art project. Like, look at these. I
Oh,
like
so
to
pretty.
coordinate my colors too. I like to make it look pretty.
That's so cool. Yeah, if chemical engineering doesn't work out for me, maybe I'll go into that. It sounds so cool how you can like make art out of coding and wires and stuff like that. Thanks for talking about it and giving us some inspiration and stuff. Everybody thank Abigail in the chat. Yeah, it was really inspiring, and it's good to know that if for me my career doesn't work out, I've got other options out there that have to do with art or the beauty in programming and stuff like that. So it's good to know that.
Oh yeah, there's art
Um,
in every type of engineering too. Like it's STEAM for sure, not just STEM.
Amanda, one of our speakers, is raising her hand. Did you want to add anything to what we're talking about right now?
Oh, no, sorry. That was an accident.
Oh, no, you're good. You're good. Yeah, thanks again for telling us a little bit about what's the biggest thing you've done, like either the biggest circuit or the biggest project.
I don't know if I've done anything too big yet. I know next year to be able to graduate, you have to do like it's called senior design, and they put you with a bunch of students, and basically you come up with a new idea, and the entire year that you do the project and you present it, and you at the end you create an entire thing and put it on a presentation, and I'm just really excited to do that. I'm excited to meet some other engineers and come up with something cool and present it to the entire city. I don't know what it's going to be, but I'm excited.
Sounds interesting.
Yeah.
Well, good luck to
I'm
you
ready for
on
the
that.
challenge.
Yeah, give you a big challenge to work on. So it's a year-long project.
Yeah.
Well, that sounds very interesting. I hope to see how well it goes.
Yeah.
Yeah, thanks again for talking to us about electrical engineering.
See you guys.
So, speaking of electrical engineering, we have another crossword puzzle for you guys. This one has the electrical engineering keywords. Again, if you haven't been here yet before, the red words on the little lightning bolt there, the red words are the ones that you are using to fill out the crossword puzzle. We've also got the answer key there for you if you get stuck or if you finish it too. But there's already a hyphen in there for you on one of the words. That'll give you a little hint on where to start because there's a hyphen in one of the red words. But yeah, that's there for you to get to know the keywords a little bit more. So let's move on. Let's discuss. So if you have your workbook in front of you, you can fill it out here. If you don't have it, you can just fill it out in the chat. But here's a few questions you can fill out to just kind of just fill it out so that you can either look back at it if you want to remember anything, or to just kind of plug it in your mind a little more about what does an electrical engineer do? What can an electrical engineer create? What special things do they know about? So if you have your workbook, you can do it in the workbook, or if you don't, you can put it in the chat for me to read off to you guys. So again, what does an electrical engineer do? What can they create? What special things do they know about? UJ says they know about electricity and circuits and etc. Yes, electricity and circuits are just a few of the many things that they can do. Electrical engineers create circuits that can make a lot of things that we use today, such as your phone, your computer, or all the way up to a power line. Yeah. It's crazy. I remember hearing somewhere that they've been able to make a camera that is smaller than the tip of your finger. It's crazy. Anybody else have anything to say about these different questions? An electrical engineer solves problems using their knowledge of electricity, electronics, and electromagnetics. Yes, that is exactly right. But yeah, with electromagnetics, electricity is able to create a magnet because it gets all of the south and north poles to line up, and then it creates a magnet. I personally think science/math has come too far. What do you mean by that? Anybody else have anything to say about the three questions? I want to share their answer that they've written down in their workbook. We are able to do so much that we shouldn't be able to do. Yeah, we've gone so far. Like how we started off, like I don't remember when the phone or anything was created, but we've upgraded a lot of our technology really fast, and I just don't get how we can grab the things that are naturally here on Earth and create all of these many different things. But yeah, also one person doesn't have to know everything. That's why we have so many different types of engineering. So like with civil engineering, they focus more on the construction side and building different buildings and stuff. They focus more on that section of engineering. And since there's many different types of engineering, so certain people can focus on that topic and learn it and know everything about it so that that engineering can be the best it can be. They know that negative and positive electrons attract to each other. Yes. Anybody else want to share their answer that they wrote down or typed in the chat? I'll give you, anybody who isn't finished filling in anything, raise your hand so I can see whether or not we can move on. Okay, we have one hand raised. Okay, the hand is down. Okay, so let's move on to the filled in version of this so we can go through it a little bit. So what does an electrical engineer do? Electrical engineers solve problems using their knowledge of electricity, electronics, and electromagnetism to develop solutions. What can an electrical engineer create? Electrical engineers design solutions for anything that plugs in, uses a battery, contains a motor, has a microprocessor, or uses radio waves. For example, in cell phones and Bluetooth, there's radio waves. Shelby says they know all about math. Yes, all engineers know a lot about math and science. What special things do they know about? Electrical engineers design and program systems using coding, circuits, magnets, conductors, coils, switches, resistors, capacitors, inductors, transistors, and semiconductors. That's a lot of big words, but again, you don't need to know everything about this. This is just a little like intro to electrical engineering. So if what you're hearing so far sounds very interesting to you, then you get to learn more about it over time as you become an electrical engineer, if that's what you're interested in. So you don't need to know everything right now. This is just kind of an introduction to kind of jog your memory with what types of interests go with what type of engineering. Someone else rose their hand and put it back down. I think, are we ready to move on to the next thing, guys? Or does anybody else want to share anything? One more hand raised. Okay, we'll give it a few more minutes. But yeah, it's crazy how like the sizes of how small or how big these electrical circuits can be, and how a tiny little thing can be like give you so much. Like what Abigail was showing, she had a microprocessor. I think it's called a Raspberry Pi, but that little tiny thing is a fully working computer. I still don't get how this all works, but it's just amazing how far we've come over time with technology and improving things. Yeah, and without improvements and without trial and error, we wouldn't be having many of the stuff we had today. So they didn't get on their first try. They didn't get the iPhone or the Android phone on their first try. They had to improve it over time. So again, you need to get things on your first try. So one more hand still raised. We won't move on yet. We will in just a moment. Anybody else have any comments on electrical engineering? Oh, by the way, this page that's filled in will be on the Facebook page. So if you haven't filled it out yet, or if you're going to fill it out later, if you don't have the workbook in front of you, it will be on the Facebook group for you to look at later. Emily says, I think I want to be an electrical engineer or a civil engineer. That's really cool. Yeah, like electrical engineering can bring you to a lot of, like it can help you create a lot of art and like beautiful things out of electrical engineering. And with civil engineering, you can build just beautiful and amazing buildings. They know all about lightning. Do they know all about lightning? I'm not fully sure they know about lightning, but that's interesting. Abigail, do you guys know anything about lightning, or can you like harness the energy from it or anything?
I don't know if we necessarily touch on lightning. I mean, sometimes we will talk about like renewable power systems, like we'll deal with like hydropower, which is like harnessing water for energy, or wind power or solar power, things like that. So we do kind of pay attention to like how to harness energy from the earth and the weather and things like that.
Well, Sahasra, maybe you've come up with something. Maybe in the future you'd want to find a way to power things with lightning. But yeah, lightning, it's like How do I explain lightning? It is like a surge of energy that strikes the ground, but I don't know if we figured out how to harness that energy yet. So that's something to think about, definitely. If you're interested in electrical engineering, maybe you can invent something for that. Who knows? I don't think we've come that far yet to be able to harness the energy of lightning, but it's a really good thought because lightning is power, I think. Not fully sure, but if you want to look into it, that sounds very interesting. Because we've got solar power, wind power, water power. We have many ways to power things. We have technology for it, but it's way too expensive. True. But again, like as we improve things, we're able to find more efficiently priced things and make things lower cost. Like I remember like 10 years ago, televisions were hundreds and hundreds of dollars, maybe even thousands. And now you can get the same size television for like a fifth the price. So they find more cost efficient materials over time. That's another thing that people improve over time. If someone thought they got it on the first try, then there's no room for improvement and improving technology over time. So they didn't get it on their first try. They had to use expensive materials. Okay, so I see all the hands are down. So let's move on to the next page. So we're going to talk to more women engineer role models. So how about all of the engineers that are here, turn on your cameras and let's have you guys introduce yourselves. Let's start with Amanda, who has her camera on, I see on the front screen. Let's start with you. Tell us a little bit about yourself.
Hi, all. So my name is Amanda. I am a graduate student at the University of Illinois right now, studying nuclear engineering. So first of all, graduate student means I already have my bachelor's degree. I'm pursuing an advanced degree, so either a master's or in my case, a PhD. So I'm trying to become Dr. Amanda someday. And so what is nuclear engineering? Nuclear engineering is all about how we can utilize radiation and nuclear processes in order to solve problems and make people's lives better. So, radiation, kind of the scary thing that you think about of just a lot of energy being released at one time. We can use that a lot of times to help people. We have nuclear power plants all across the United States. They make up about 20% of all electricity in the United States and about 55% of all clean electricity in the United States. So nuclear energy is not a carbon emitting energy source. We also utilize radiation a lot of times in medicine. So if you guys have ever had to get an x-ray for a broken bone or an x-ray of your teeth at the dentist, that's utilizing the nuclear process, looking at how x-rays interact with your teeth versus like your skin, and we can get an image of that and look kind of inside your body based off of that. And then we're also looking at nuclear power for different satellites and space missions. So right now we're looking at nuclear a lot to help us get to Mars right now. So it's such a vast field and it's so exciting, and I'd love to be a part of it. My work specifically, I stay mostly on the nuclear power side of things. So my research in school right now is working on the nuclear fuel cycle, which is how we get uranium and other materials that we need in order to make fuel for our nuclear reactors. How do we process them into a form that we can create the fuel and like put into a usable form for our reactors? And then when the fuel comes out of the reactor, what do we do with the fuel in order to properly dispose of it? So I would love to answer any questions y'all have about it. I know nuclear, like I never heard about nuclear engineering until I was like in high school, and that's only because my brother majored in it. Otherwise, I may have never heard about nuclear engineering. So I really hope you guys are excited to and ask questions about it.
So which of the core four, or if there's more than one of the core four, which ones does nuclear engineering branch off of?
I would say it mostly branches off of mechanical. Sometimes at a university, if they have a nuclear engineering program, it might be within a mechanical engineering program. Since a lot of what we do focuses on nuclear power. So, the thermal energy systems and whatnot, that was kind of a branch off of mechanical. That'd probably be the biggest way we do it, but it is also related to electrical engineering because it's power and transmission and how can we, get power onto the grid for people. But probably closest to mechanical.
That's interesting. So it branches off of mechanical. Gotcha. Oh, power plant. That was one of the ones that branch off of mechanical. Okay. That makes more sense now. I was wondering where it fit into the core four. Someone asked, is it bad to get too many x-rays?
So certainly, radiation can definitely adversely affect our body, so harm us. And so we have to, be aware of when we utilize nuclear medicine, how much dose, similar to like, if you have to take other medicine, like when you get sick, how much dose of the medicine are you getting? There is generally kind of a threshold where we make sure that we don't, provide a certain amount of dose or anything over a certain amount to a patient. That's why like when you're at the dentist and you have to get your x-rays, they put that like really big, heavy covering over your body to kind of shield the x-rays from the rest of your body so it stays localized to where they need it to be. So, if your doctor recommends x-rays or any kind of nuclear medicine, definitely trust that it's in your best interest and that it is not going to harm you. It is only meant to help you in some way.
So when they put the lead blankets on you, is that just to minimize the amount that you get of like the nuclear?
Yeah. So it kind of lead is a really good shielding material for x-rays is kind of what we call that. So, what the amount of x-rays that you'll have on the other side of the lead is significantly less than what you'll have before the lead. So that way it like reduces the x-rays that go to the rest of your body and reduces the dose that you receive.
Gotcha. Someone else had asked, has anyone said that you couldn't get to where you are, or have you ever hit like a breaking point? What, if you want to share, what was that and how did you get through it?
So there's definitely been, small individual hurdles of like getting through tests and different exams and, grad school admissions and getting funding for that. But I have been super fortunate enough in order to, not ever have someone tell me directly to my face, like, no, you can't do this. I've been able to primarily surround myself with very supportive people. And I think, those in nuclear engineering tend to be really supportive of each other because we know that like we're a really, really small community. So, we just want to be there for each other and uplift each other. I've also been able to find myself some really great mentors as soon as I started college. A lot of my different professors, some of the people I worked for at internships, some of the people that, I've just networked with over the years. They've always been there. Like they make sure I know that they have my back, that they're willing to write recommendation letters for me, just sit there and let me vent to them if things get really frustrating. So that has been a really important part of my career so far, is just finding those great mentors and then that supportive network to just surround yourself and kind of insulate yourself with. So that way you can, block out all the haters.
Well, that's good. I'm glad you like found a way to get through that. Like, do you ever get like, what's it like being in your field? Like, are there a lot of women or they're mostly men? And if there are mostly men, how have you been able to reach out to find women in your field?
Yeah, so nuclear engineering is still a male-dominated field. We're slowly getting more women into the field and also retaining women in the field. I think, become pretty aware of that and are trying to do better about it. And so, but, the real key there is, once again, like finding that support network. I think sometime after like my sophomore year of undergrad, like all of the women that were in like my graduating class, I think we all just kind of were like, I'm really tired of just like independently, we all thought this, and like, it was kind of a really cool moment. Like we all just kind of thought like, I'm really tired of like only hanging out with the guys. Like I need to actively like seek out women in my field and like hang out with them and like become friends with them. So after like starting in junior, we all became really close. We're all like best friends and probably be like bridesmaids at each other's weddings at some day if they happen. But there's also a lot of really great professional societies and networks to help with finding other women in your field. A big one for across all of engineering is called SWE, the Society of Women Engineers. So just, they do a lot of professional development and networking across all fields of engineering. So that way you can, find your people, find that supportive network, help others out. In nuclear specifically, we have an organization called US WIN, US Women in Nuclear. So it's just, focused mostly on the nuclear industry, but same idea of professional development, trying to help each other out, be that supportive network and help you connect with other women in the field. And what's kind of nice about US WIN is it's not just the nuclear engineers or even just the engineers. It's any woman or or really anyone, regardless of gender, that works in the nuclear industry and wants to help close gender gaps and make things more equal across genders within the nuclear industry. So that's also been a big component of just finding those networks and getting engaged and staying connected with people.
That's cool. Do you know if those networks are present in all engineering fields, or like just Society of Women in Engineering is like a really good one? Like, do you have any other ideas for if there are ones for different fields?
Yeah, Society of Women Engineers Suite is definitely like the biggest one. And if y'all do end up majoring in engineering of some kind, whatever campus you go to most likely will have a chapter of them. There are some other like industry specific ones, like there's WISE Women in Industrial and Systems Engineers. Sometimes there's like campus specific ones. So at my undergrad institution, the University of Tennessee, there was, it was called Sisters, spelled SYSTERS. And that was an on-campus group specifically for women in electrical, computer engineering, and computer science. So kind of like that department. So I don't think there was necessarily like a national program, but there's at least something on campus where you could connect with other women there with you.
That's good. I'm glad that there's that option out there for women who don't have a lot of people in their field. Somebody else asked, what different courses or challenges did you have to go through to reach the point in your life that you are at now?
Yes, that's a really good question. So, certainly throughout my undergrad experience, I had to take all the engineering courses. I had to take some like pretty, we'll say like typical or, classes that a lot of engineers have to take no matter what discipline they're in. So, I had to take like the intro to engineering classes that all the freshman engineers had to take. I had to take, a circuits class. I had to take a thermodynamics class. But then I also, had a lot of department specific classes about, how do we measure radiation? How do we operate a nuclear power plant and make sure it's going to perform as we expect? I took some elective classes in, the nuclear fuel cycle, because that's what I knew I wanted to focus on with my research in my later career. I also got a minor in material science engineering. So looking at, not necessarily a little bit of how do we fabricate materials, but more of like, what's the science going on behind materials? How are atoms organized within a material to, make it stronger or make it more bendable and flexible, that kind of a thing. So that was really cool. Some different challenges were definitely balancing a lot of things on my plate. There's definitely something you'll hear a lot once you get into like a little bit of high school and definitely into college is like resume building. So, what have you done that's related to your field that shows that you have experience and talent and leadership, whatnot. So, I had all of my classes, but then I was also doing undergraduate research on the side. I was also working another job on campus. At one point, I was a leader in the US WIN chapter at our campus. So just, juggling a lot of things and figuring out the time management skills in order to be successful in whatever I was going to be pursuing.
Seems like you've been through a lot throughout your nuclear engineering career. My question for you is, how do you guys keep yourselves safe from like overexposure to nuclear, like to all that stuff while you're working close by to it?
Yeah, that's a really good question. So there's So one thing, we pretty well understand how different types of radiation and different sources will affect our body, or not affect our body even sometimes. So there's alpha decays, if you ever hear of that, if alpha particles, like they hit your skin, they don't actually like penetrate, and they're not going to do any damage whatsoever. So if there's an alpha source near you of some kind, we're kind of like, okay, I need to know where it is, but not a big deal. So we're aware of like, if I'm in this strong of a field for this long, like this is kind of the damage it can do to me. But we have three basic principles that we adhere to within nuclear engineering: time, distance, and shielding. So we limit the amount of time that we're around sources, because the longer that you're around a source, the more dose that you can pick up, the more damage it can do to you. So by limiting that time, it can reduce your dose and the damage. Distance, so radiation will only travel so far through air, and the farther that you farther away from the source that you are, the less intense the dose is. So we try and keep distance from different things of maybe we keep whatever tools we're working with, fully at an arm's length away. So that way it's, maybe affecting our hands, but not as much our whole body. We use different tools to like extend, sometimes like we'll use giant poles to like kind of move things around if we need to. So that way we're farther away from the dose. And then that last principle is shielding. So I kind of mentioned that big, heavy lead mat that you get on your body at the dentist. So just, are there any materials we can put between ourselves and any sources to protect ourselves and, limit the doses that we're getting? We also, we kind of call ourselves nuclear professionals. So anyone that's working in a nuclear field, we are fairly aware of these risks. We've accepted some of these risks, but the government does have an agency called the Nuclear Regulatory Commission. They are charged with all regulations regarding nuclear sources and operations and whatnot. And so they do have limits on how much dose we can receive, within a certain time period. And we are very closely monitored. When I was working at a power plant for an internship, if we ever had to go into certain parts of the plant, we had to wear what are called dosimeters. So just like a little badge that we wore on our chest that would track how much dose we were receiving. Working on some of the campus labs here, we also have to wear a dosimeter. Including what's really cool, actually, it's a ring dosimeter. So it's just the little like plastic ring that you would wear on your finger and would, you can compare how much dose your hands are getting versus like your whole body. And so those are really cool. So it's a lot of, being aware of what's going on and then figuring out, how can we engineer things in order to protect ourselves. That's also a big component of nuclear engineering.
Glad that there's ways you guys can keep yourselves safe throughout this career so you can still improve your technologies and power things around you with nuclear power. Does anybody else have any final questions for Amanda about nuclear engineering? Well, one final one. Was there a moment that you knew you wanted to be an engineer? Like, when did you know you wanted to be one?
So I was fortunate enough where growing up, like my dad is an engineer and my mom is in the medical field, but kind of has like engineering tendencies of like, she loves problem solving and that kind of a thing. So I always kind of grew up like in that kind of culture within my home. My brothers and I loved playing with like Legos and Lincoln Logs and like building different things that when we were little. So, kind of like some tendencies there. But the like real moment when I knew that I wanted to be a nuclear engineer, and this is going to sound so corny and cheesy, but I was really bored in study hall one day my sophomore year of high school, and I happened to be in the physics teacher's room for my study hall, and I just started reading the physics textbook. And I was like, wow, this is really cool. Like, this is what I want to do in my life. I want to, control elements and whatnot, because one of the like characteristic things about nuclear processes I mentioned earlier is like, if you think about like chemistry and chemical engineering, you have all of your different elements and your reactions, and whatever elements you start with, you have to end up with. So if you start with carbons and hydrogens and oxygens, you have to end up with carbons, hydrogens, and oxygens after the reaction. In nuclear, in nuclear physics and nuclear reactions, that gets thrown out the window. If you start with carbon, you could end up with another element. It basically breaks all the laws of, chemistry that I had already been learning. And I was like, this is way too cool. This is what I need to be doing with my life. So that was really the moment that I was like, yes, this is for me.
So you guys work a lot around chemical reactions, I hear. Is that right?
No, not so much chemical reactions, but nuclear reactions. So lot smaller scale of, chemical reactions. It's the breaking of bonds between atoms and like forming them into molecules and reforming molecules. Nuclear reactions are what happens inside a single atom. So, typically the nucleus just has a lot of energy. So you can kind of think of like when you guys all like eat too much candy and too much sugar and you get really, really energetic and you just want to start running around and creating havoc, and your mom yells at you to like sit down and, this is why you shouldn't have that much sugar. Like you can think of it as like an atom gets really excited, has a lot of energy like you. And so it needs to release that energy in some way. And so that's all radiation is. And that's what a lot of nuclear processes is, how it releases that energy.
Gotcha. Because when I was in my first chemistry class, like last semester, I learned a little bit at the end of the course of like nuclear reactions and how they have like more of, I think, neutrons or protons, but it's cool how they link in some way and how your reactions are more in the singular atom than with breaking groups of atoms apart. So that's really cool. Two more things. How hard is nuclear engineering, and what's the coolest thing you've done?
So how hard is nuclear engineering? I think it definitely has a perception of being very hard because like for some reason just people hear nuclear and they're like, whoa, like that's gotta be really hard. It definitely has its challenges and its difficulties, just like any discipline of engineering. But I think, sometimes things come more naturally to some people than others. And so some people might have to like work hard, but I think, it's definitely a field that you may have to put a little more work into it than, other fields, but it's very manageable. It's pretty on par with other fields of engineering. We're just a little more specialized than, like mechanical engineering. And then the other one was, what was the other question?
What's your, shoot, let me go back to it. What was the coolest thing you've done?
Coolest thing I've done. So I've mentioned that I did some internships at a power plant. So there were some really cool things I got to do during one of the summers doing that. And there's two big, like really cool things, which some of it is like cool to me as like a nerd and really loving my field. But they're cool. So one of them is that summer we were doing what's called a dry cask campaign. So right now, when fuel comes out of a nuclear reactor, we set it into a pool for like 3 or 5 years and just kind of let it cool down because it's really hot temperature wise and radiation wise. So we're like, all right, you can go chill out for a couple of years. Once that time is up, we stick them into these dry casks. So giant cylinder canisters made of like metal and concrete. And we just load these fuel assemblies into these dry casks, and then they go sit out on like a parking lot at the reactor. And so I got to watch one of these dry cask loading campaigns one of the summers, and just seeing all of the technicians and maintenance people work and handle the fuel and everything they were doing. It was really cool to watch. It was great hands-on experience for me wanting to work in fuel cycles, but it was awe-inspiring to watch these guys work and just how skilled they are at their jobs. The other really cool thing I got to do that summer was I got to go into what's called upper containment. So I was basically a level above where like the actual reactor core was. There was, like a level of concrete and whatnot between us. So I wasn't, picking up dose, but we were monitoring it. We had different personal protective equipment on to help protect us and whatnot. But it was really cool just to like basically be in the reactor and, you know, be like, oh, here's the steam generators and here's this component and that component. And like below me is a bunch of like fuel and neutrons flying around and making power. And it was just such a really cool experience for me. It's definitely something a lot of people don't get to do, even if like you work at a power plant full time. So it was really unique and just really cool for me to sit there and be like, wow, I have this. And that's even better because I have a picture of me in copper containment as well. So that was a nice little souvenir.
That's really cool. I think you already answered this, but what was the hardest thing you've done? And I think that's gonna be the final question for Amanda before we pull the other two back.
Sorry, I was on mute. So definitely
yeah.
one of the things I struggled with a lot throughout college and even like now in graduate school is just a lot of time management. So, you know, learning when to like schedule different things to make sure you get all your work done. But then also sometimes like you don't have a whole lot of work. So, you know, what do you do in those times? Do you try and get ahead? Do you relax? Do some of your hobbies, hang out with other people? So, you know, just a lot of time management has been something I've struggled with. And especially, you know, I say yes to a lot of things. So when people are like, do you want to do this and like do this and whatnot, as far as, you know, a lot of extracurricular activities, I'm usually like, yes. And now I'm having to learn how to say no. So that's been really hard over the last year or two. So related to time management, but that's been a lot of it.
So it may be a little harder than the other engineerings, but at the same time, it's not. You just gotta keep going with time management and keep yourself pumped that soon enough you can get into the career you want within the engineering that you want.
For sure. And like I said, really small community, but really supportive. So once you get in, you can find your niche, find your people, and you'll be great.
That's good. I'm glad. And this asking all these questions, even for me, was it's calming me down with knowing that soon enough I'm gonna have to get into it and start planning for my careers and stuff like that. So it's not only, I think, inspiring them, but calming me down and getting me ready to move forward into my college career and get internships and stuff like that. So thank you for answering all these personalized questions. I think now we're going to bring Abigail and Emily back and do some more generalized questions. So we'll also spotlight you guys. Still getting it. Okay, got it. I think we have already answered this, but one of the girls is asking how hard is nuclear engineering. Again, is it not harder, but a more specialized and like smaller field?
Yeah, I would agree. It's, you know, comparable in difficulty to other fields of engineering. Like, you know, I'm not an expert in everything, but like definitely if Abigail really gets into some of her electrical engineering stuff, like it's all black magic to me. So, you know, it's definitely not the hardest. Really depends on your individual strengths and weaknesses, but it's definitely a field where, you know, as long as you put in an appropriate amount of work, same as other engineering fields, you'll be good.
That's good. Yeah, just time management. Keep yourself positive. It's getting hard. Don't give up and just get to know the people within your field and find some friends and study buddies, and you'll get through it, guys. So now that we have all three of you here, does anybody have any generalized questions that you want them each to answer individually? Like, for example, let me see if like a start off question. How would you each advise these girls keep engineering as an option for them in the future? That's a good starting question. How about Emily start first and then we'll move on.
Yeah, I can definitely start off. I would definitely say to just try and take as many STEM-based classes as you can and to really explore like all of your options by taking chemistry and bio and physics to see like what kind of engineering you might want to get involved in, and also like looking out into your community and seeing if there's any engineering or STEM-based camps like this that you can also get involved in.
Abigail, how about you?
Yeah, very like same thing. I remember when I was in high school, I joined it was called Women in Science and Engineering, and it was something kind of like this where once a month we went to the ESSL in downtown Frederick, and we went to talk, or a bunch of engineers came and spoke to us, scientists, women engineers, and they came and spoke to us about their careers and stuff. And then we would do like an activity, something literally just like this. And I was so excited about going every week. And that was something that I looked forward to throughout my entire high school career. So like just reaching out and like trying to find things in your community to keep you engaged, or keep like always looking for new things, like always proactively looking to keep learning.
Yeah, I mean, great advice. That's advice you'll hear a lot of, take your STEM classes, try and do different programs if, you're nearby, especially check out like your local libraries. A lot of times they'll have different things over the summer. If you're fortunate enough to live near a university with an engineering program, they'll do a lot of programs over the summer for sometimes middle schoolers, but definitely high school students. But also, I think a big thing is just stay curious. A lot of engineering is problem solving. So, Ruby talked about asking questions. Ask questions to understand the material, but then also think about like, okay, but what if we did this instead of that? That's a lot of that thought process that goes into that problem solving for engineering.
Sorry, someone can't see you guys, so I'm trying to fix that right now. But yeah, just also along with sticking in engineering, keeping it as an option in the future, I am still figuring out the website for following up with this camp, but on the website we'll have a few links for different STEM or engineering groups that you can try to find different camps. Let's see. Try removing spotlights and just have it be gallery view or something. Try to fix this so they can see all four of us at the same time. How about now? Can you see all of us at the same time now? No.
Are you on gallery or speaker view?
I put it on
gallery.
Gallery. So attendee view is gallery, and my view is also gallery.
This is a great example of, engineering problem solving.
Yeah. She saw you for a second, so you might be in speaker view. I just changed to follow host view. Does that change anything? I think with doing more than one spotlight, I think it just upgraded which person went to spotlight. Now it's switching around, but it was all four at first. That one, spotlight didn't work. That's what it was at. Let's try doing spotlight one more time. So let's spotlight you guys, and if that doesn't work, then see what we can do to fix that. Okay, does that do anything for you? No. So it looks good for the panelists, but not the attendees. Only one person. So can you guys see me right now since I'm the one speaking? Okay, so some people can see everyone, some people can't. If you aren't in full screen for Zoom, put yourself into full screen, like make it take up your whole screen, because maybe that might work. Sometimes when you're in small screen, it like starts to, yeah, or if you're on a phone, not sure. Do you guys have any ideas, or have you not used webinar before? I saw all of them for 1 second.
I think if anyone's on a phone, it's only going to show you one person at a time.
Well, when you're on a phone, the first screen shows only speakers, but then when you like swipe it, it brings you to everyone. I'm in full screen, I'm not on a phone. Okay, so raise your hand if you can see all 4 of us at the same time. Okay, so we got 6. Do you see whoever is talking? For when you see whoever is talking, are you on a computer or what type of device are you on? Laptop. I feel like laptops would be showing it all because I thought Spotlight brought. See. Well, I mean, at least, okay, so lower the hands, raise your hand if you can at least see whoever is talking when they're talking. Like if I'm talking right now, you see me, but then when someone else tags in, you see them. Is that how it's working? Like it's either, so I see everyone at the same time. So either put your hand up if you can see us all at the same time, or you can at least see one of us when we are talking. Because I'm just trying to see if it's like good enough so we can move on to asking more questions. So if it's perfectly fine, you can see all 4 of us, or if you can see the speaker, at least raise your hand. Well, I mean, at least you can see all of us. I can see whoever is talking, and if someone else starts talking, switches to that person. Yeah, okay, so people who have the same situation as her, raise your hand. Keep it up. Someone just left. If you're on a computer, you can change the layout and see all 4 of them at the same time. Yeah, the layout I think you want to choose is gallery. So if you have the option to change it to gallery. I think, yeah. What's immersive do? Oh, no, we don't want to do that. You cannot. Okay, so yeah, it's a webinar. It's kind of weird. How can you guys at least see me when I'm speaking, and if it changes to someone else speaking, it moves over to them? Are you able to see it like that? Is that how it's working for you guys? I think we need to move on and ask more questions. So everyone lower your hands and just kind of, I'm pinned. Here, let's remove all the spotlights and just put us in. Is it in speaker view right now? Can you all see me right now? Yes. Yeah. Okay. How about we just do speaker view, because it's only one of us talking at a time. So I think that's good enough. So everybody, if you want to ask them a question that all of them will answer, like a generalized one, like for example, why did you choose your engineering or something like that, something that all of them can answer together instead of instead of personalized. So everyone give us some questions. Okay, so how about we start off with, which of your projects are you particularly proud of? How about Amanda start? Which of your projects are you particularly proud of?
I think in general, like you have some amount of pride in all of the projects that you do. Maybe not all of your class projects, because sometimes you're doing those the night before and don't have a lot of time or energy to finish them. But at least like big projects you do, you have some amount of pride. I think probably my project I'm most proud of right now is the work I'm currently doing for my PhD. So some of that fuel cycle research, just because, it's first of all going so well. I haven't made any big mess ups or mistakes on things, but it's also really timely research for the nuclear industry, and I'm hoping it can answer some really big questions that people have regarding the fuel cycle.
How about Emily? What is a project you're proud of?
So I'm still pretty new into the whole like engineering field. I am just a rising sophomore. So I haven't had a ton of time to be able to do a lot of projects, but the one that I've definitely done my freshman year that I'm the most proud of is I had to take an intro to coding class basically. So we learned how to code in a language called MATLAB, and it's a really cool coding language. If you ever learn how to use it, I like it a lot. It's a lot of fun. And we had to basically create 3 different apps or like features that could be put in an app that could be used to help organize hands-on clubs to meet during COVID. So, and it was very open-ended. So I was in a group with 2 other engineering girls, which was a lot of fun that I was able to do it with other female engineers. And we just created 3 functions, and it was like, the functions we did were like, how, like if you're feeling sick, and like if you're feeling sick, how long have you been feeling sick? You shouldn't meet in person. If you aren't feeling sick at all, like where you can go to meet for your club. And then we did one where like different directions on like around campus, because I go to the University of Pittsburgh, so we did directions around our campus where your club might meet. And it was a ton of fun because it was very open-ended. So we had a lot of creative liberty for what we could do. And I never thought I would be able to code something so cool. So that's why I take a lot of pride in it.
That's really cool. I'm kind of interested in coding too, because it's all like an intricate like page of words that all go into programming something to either do a simple task or really like intricate task. How about you, Abigail? What's a project you take pride in, either within college courses or in a job if you have?
There was a class that I took last year in my junior year. It was called Digital Logic, and basically they taught you how to use math to then code your computer. And so that blew my mind basically. And the first thing that we learned how to do was get a little screen to produce, like, to say words and stuff. But you had to literally program each little like section of the letter. So it took a long time, but eventually we got it to say spring 2020 on the little screen. And so I like took a picture of that and I was like, yeah, I did that. And I was very, very proud of myself.
That's cool. I'd be proud of that if I ever did that. How long have you been doing engineering? Like, how long have you known that you want to be an engineer?
I'll go first.
Yeah, sure.
I think I've always known that I wanted to do STEM, something with science, something with math, because I've always just loved the puzzle aspect of it. And I think I decided I wanted to be an engineer in the beginning of high school when I started going to the Women in Science and Engineering lecture series, because those women were just so cool and so inspiring. And I was like, yeah, that's what I want to do. I want to be like them.
So for me, I like Abigail, like I've always known I wanted to go into STEM. And I originally wanted to be a doctor. So it was a lot of like trying to figure out what to major in. as like an undergrad, because you can't just do pre-med. That's not like a real major. You need to get like a real major. So I had tossed around the idea of chemistry because I was really into chemistry. And I also knew like if I didn't want to become a doctor, I needed a backup plan. So my backup plan was to go and make into pharmaceuticals and to make medicines, because that always also interested me. So it was a matter of more so just like researching like how, like who makes medicines and like what kind of field to go into. And the answer was chemical engineering. And once I like looked more into it, I was like, yeah, this seems like a good fit for me.
Yeah,
That's
pretty, oh, go ahead, Ruby.
Oh yeah, I was just saying how it's interesting how like how the way she chose it, and also to note that she didn't have a clear plan on what she wanted to be at, and that's okay. So I wanted to let them know that it's okay if you don't know what you want to be yet. This is just a session to give you the basics around some types of engineering, so you have some ideas than other than just engineering.
Yeah, it's pretty kind of similar as Emily for me, of like growing up. I really, did think about medicine, my mom being in the healthcare field. Like I really thought that was what I wanted to do. And then I read that physics textbook and it was no engineering all the way, gonna go do nuclear. So that was my sophomore year of high school, and I've been in school for nuclear engineering for about 6 years now. I also do want to say, related to Emily's point of like, if you don't know exactly what you want to do or something, that's okay. A lot of colleges within their engineering programs have a pretty common curriculum for a lot of freshman engineers. So if you're like, I want to be an engineer, but I don't know what type yet, that's totally okay. You will have basically your freshman year to kind of explore different majors that they offer in different fields within engineering. So that way you can really figure out what you want to do within engineering.
Really quick, I want to say something off of what Amanda said. So like for me, my freshman year, we took a class that all we did was listen to different professional engineers from every single discipline of engineering. And like that course was designed to help kids who didn't know what they wanted to go into to figure out what they wanted to go into. So it really is okay if you know you want to do engineering, but you don't know what kind, because they will help you figure that out.
Yeah, that is very much true. And the camp that we are in right now is kind of like the same thing, but for your age level. So it's going to be kind of like that, but more longer. Isn't it a class? Okay, yeah, it's a class. What is the most interesting product that you have completed or are working on right now, either within your college career or on the job you're in right now? How about Emily start?
So I don't really know if I have I guess a good answer for this. Again, like I haven't done a whole lot. Really just like my favorite thing was that MATLAB code that I made. But other than that, I haven't really had a lot of experience working in the chemical engineering field, because like your first year, you really just like learn kind of the basics and like get a foundation in engineering. So sadly, I don't have like really an answer for this, but I'm sure the other two will have wonderful answers.
How about Amanda next?
Yeah, so the most interesting product. So my research specifically is falls under computational research. So all of this like coding and programming that we're talking about, like that's the basis of my research. I, code computers and tell them how to like solve equations related to nuclear engineering. So just a lot of like the coding scripts that I've written, are pretty cool. And then also a lot of the coding and software that I'm using for my research. I'm more in like a user realm. So I'm not a developer. I'm not like writing all this code and figuring out how to tell the computers as much. I'm more like in the user realm for things. So it's just really cool, like all of the, different abilities and components tied into some of these codes. So it's not something I've like made personally, but the code I'm using actually my PhD advisor wrote as part of her PhD. So like it's also really cool of like, that legacy there. So
That's really cool. It seems to be a trend that many different engineerings use coding.
Yeah, it's definitely becoming a bigger field, especially if you guys have heard about like AI and machine learning. So, Ruby mentioned earlier, like optimization. So sometimes engineers just sit there and like run these simulations and figure out how can we optimize whatever this process or what we're doing is. That's becoming a bigger part.
Yeah, definitely. How about you, Abigail?
Recently my dad and I ordered a Raspberry Pi. Ruby kind of talked about that a little bit. It's different than my microprocessor, but it's similar that it is a tiny computer. And so I just finished like putting it together. It's right here and it's in like a little box. And so I can take the top off and then you can see the little computer inside. And so right now I have my TV hooked up with Netflix and stuff, but I can take it apart and then plug it into this, and then I can set it up with like my mouse and my keypad, and then I can go use my TV as a computer, and I can plug this in there, and it's really cool. It's a good time.
It's crazy how it's a tiny little computer.
No, it's
still
literally
unfair.
a box. Like this is a whole computer, and it's like a little phone.
Aw, it's really cute. So how about we just have you answer both at the same time for each of you? Why did you become an engineer? And again, is it mostly male populated for each of your professions? So how about Abigail start first?
In there, it's definitely electrical engineering is definitely male populated. There were most of my classes, I was the only girl. There was maybe one other girl, and she was my lab partner every time. But I really just learned that if you make that connection with your professor, sit in the front of the class, have confidence, like the boys are gonna ask you the questions, they're gonna ask you for help. So that's all I have to say.
How about you, Amanda? Why did you choose to become an engineer, and is it mainly male populated?
Yeah, so I chose nuclear engineering over like maybe nuclear physics, because with engineering, you're really like helping people. Like nuclear physics is more of just like, okay, I want to understand more about whatever's happening here. But with the engineering part of it, it's producing that clean energy and helping people with medicine and whatnot. And so especially, and this is kind of like a trend amongst nuclear engineering students, more and more people are going into nuclear engineering because they want to try and address climate change. Nuclear energy is our largest source of clean energy right now in the United States, and it's the second largest source of clean energy in the world. And so there's been a lot of articles of like, we're going to need nuclear engineering and we need to scale up nuclear engineering, build more nuclear energy, and build more plants in order to like really meet a lot of these climate goals. So we're very motivated of like, we want to save the planet and be good stewards of the environment and not continue polluting it. And I did mention earlier, nuclear engineering is pretty male dominated. It's, we're aware of this problem. We're really trying to address it and, be better about things. I was actually fortunate enough where about a third of my undergrad class was women, which is really high. It's normally somewhere around like 20%. So, it was nice to like have a lot of women that like we could surround ourselves with. So that was really nice. But yeah, as far as what Abigail said of like sit in the front of the class, engage with your professors, and even like when you guys get into like middle school and high school, like talk with your teachers. Like they love talking with students. They love spending time with you, and answering any questions you have. So like it's a great way to like get started in things and stay engaged, and eventually get the guys to be asking you questions because you understand it better than them.
Yeah, that's a good point. Be sure to ask questions whenever you have them. And I mean, the more questions you ask, the more better relationship you have with your teachers and the more help you will get if you ever have any issues in any classes or just like staying focused on your goal of becoming whichever engineer you want to be. So how about you, Emily? Why did you choose engineering? your engineering, and then is it mostly male dominated?
So I chose my engineering. Again, like specifically because it was the best major for what I then wanted to go into. But I've also always kind of liked engineering. My brother was an engineering major. And I love how like I'm able to do all of my STEM classes, and like really it's not just like chemistry. I get the physics aspect, I get the coding, which I never thought I would like, and here I am, like I love it. So I really love like just like how much more you get in engineering than suppose a different degree. And chemical engineering is also male dominated. However, it is not as male dominated as some of the other engineering fields. There is a big chunk of women who go into chemical engineering, so that's exciting, but definitely still male dominated.
And then the final question is, what types of courses would you take in high school to move forward into engineering? How about Emily start?
So I would definitely say, again, as many STEM classes as you can take. AP classes are really good. Those are advanced placement classes. In high school, I was in what's called the International Baccalaureate program, which is kind of like AP. So were you, Amanda? That's so cool. That's so wild to me. I've like never met anyone else in it. So it's kind of like AP, but it's a little bit more. But definitely any like advanced level STEM classes will definitely give you that like one up whenever you get to college. And also, I think they like just help keep your interests a lot more. They're a lot more interesting than the basic chem sort of bio classes.
And how about you, Amanda? What types of courses would you suggest taking to get into engineering?
Yeah, absolutely any science or math classes you can get your hands on. I would suggest maybe physics a little more than chemistry, but they're both definitely going to help you out. If you're close to a local community college and want to do like a dual enrollment program in high school so you can take more classes, especially if they're not offered at your high school, that's a great way to do it. I would say, a large STEM focus, but also do not, dismiss or write off like any reading or writing classes you have to take. In college and throughout all of engineering careers, like you're reading a lot of papers, you're writing a lot of papers, and a lot of people just kind of are like, oh, engineers aren't good writers. If you're a good writer as an engineer, that's going to help you stand out and make a really big difference, especially if you're like me and want to go to grad school and eventually, become a professor and stay in academia. Like you're going to be writing a lot. So, get good at it, learn, how to not write in passive voice or anything like that. And that will definitely help you stand out in addition to, your science and math background.
And then how about you, Abigail?
When I was in high school, I did take like AP calculus, I took AP physics, I took all that kinds of stuff, but like you do have to keep a healthy balance. You want to make sure you're not overwhelming yourself. I took orchestra, I took some art classes, I was a lifetime Girl Scout, I was in all kinds of stuff. It doesn't mean if you have a goal to be an engineer, that doesn't mean that you have to overwhelm yourself with school and AP classes and stuff. Like it's not like just this impossible thing that you just have to like train for. Like you can do sports, you can do all kinds of stuff. Like I remember doing everything because I really wanted to keep that fun and creative side, because you are problem solving when you're an engineer. You have to create, you have to design, so you gotta have it all. You gotta make sure you still know how to paint a picture at the end of the day, because you might end up creating artwork at the end of the day too. So you don't want to rule anything out.
Yeah, that's a good point. Don't pile too much school on you. Keep time for the things you love, the hobbies you have.
It's fun.
Yeah.
It's a good thing. Yeah, I love it. I have fun every time I do something.
Yeah, those are all good points. Thanks again for coming on today to do a little Q&A session. It helped me, and I'm really hoping it helps the campers and their parents with planning for the future in engineering. Yeah, I hope the best for all of these campers too for their journey into engineering. And thanks again for coming here and answering all these questions for us, because it helped me a lot and I'm hoping it helped them a lot. So everybody thank them in the chat really quickly. Yeah, without them, I wouldn't have a camp. Without you, without these speakers, without these campers, I couldn't have done this without you guys. So I'm really thankful. And it's so sad that today's the last day. I wish I could stretch it longer, but so on to the Kahoot. Let's share that really quickly. But so yeah, let me share that really quickly. Okay, it's 12:10. I'll start the Kahoot. This one's a little longer than the other one, so it might take a bit. It's got review from throughout the whole week. Engineering is developing solutions using blank. Yes, all of the above. Science, technology, engineering, and math. It's a part of it while using it. Got Gabby in the lead. Based off based off the color most seen in my room, what would you guess my favorite color is? This is just a silly question. Oh, a bunch rolled in at the same time. This one has no points added to it. Oh, yes, the answer is blue. Here, let's give her a second. I'll put the pin in the chat and you can join really quickly. Yeah, you can still join midway through. You just have a little less. Okay, I just put in the chat. Just say done when you have joined, and then I'll move on to the next one. Yeah, my favorite color is blue. Everything I have is blue. It's crazy. I just have like a special link to that color. Okay, well, I'll just show the scoreboard really quickly. Gabby's still in the lead. Okay. Same if you couldn't tell. Yeah, Emily had her computer blue, her airplane blue, the rubber band on her launcher blue. Yeah, both got the same color. Yeah, blue is a very, very popular color for being people's favorite color. Okay, on to the next question. Which of these are not used by mechanical engineers? Gears, wheels, chemical reactions, or axles? Mechanical engineers. The answer is chemical reactions, because in mechanical engineering, they use gears, wheels, and axles and many different other things to create their mechanisms and machines, while chemical engineering uses chemical reactions. Says you'll have to join soon. Huh. Kevin's favorite color is sky blue. Oh, that's cool. Are you in? Okay, cool. I think we just had to move on past a question. So I think you're in now. Okay, next question. Which of these are not used in chemical engineering? Chemicals, physics, reactions, or raw materials? Oh, that is weird. The real answer is physics. I don't know why reactions is an answer, but I mean, none of you clicked it. Raw materials is used in chemical engineering. They grab raw materials and they optimize them into products. So raw materials, chemicals, and reactions are part of chemical engineering, while physics, not so much. They don't use it like as one of their main things. Gabby is in the lead. Which of these are not a focus in aerospace and aeronautical engineering? Polymers, drag, lift, or thrust. Yes, polymers, you got it all right. Drag, thrust, and lift are 3 of the forces out of 4 for lift, drag, thrust, and weight. Those 3 are used when happen when it's in motion. Got Aziza in the lead with a streak. Which of these are not made by civil engineers? Buildings, bridges, roads, or machines? Yes, machines are not made by civil engineers. Roads are, though, because they're a part of the transportation area. Buildings, bridges, and roads are all made by civil engineers. Gabby's in the lead now. Which of these are designed by electrical engineers? Anything that plugs in, anything that uses a battery, anything that uses radio waves, or all of the above? It is all of the above because anything that plugs in, uses a battery, or uses radio waves is designed by an electrical engineer. Gabby's still in the lead. Next one, what percentage of engineers in America are women? 44, 73, 13, or 56? Yes, 13%. It's a very small number, but hopefully over time it grows. Hopefully over time there's more women in engineering. Gabby is still in the lead. Ruby wants to be a blank when she grows up. Mechanical, chemical, aerospace, or civil engineer? Yes, I want to be a chemical engineer when I grow up. You don't know this one? Well, I think I've said it a few times throughout the week, but yeah, I want to be a chemical engineer because I like reactions, and I also like baking because there's reactions in baking. Gabby is still in the lead. 3 players have reached an answer streak of 5. Electrical engineers use their specialized knowledge of blank to develop solutions. Bananas, chemical reactions, movement, or electricity? They use their specialized knowledge of electricity to develop solutions. Movement is a part of mechanical engineering where I thought it was bananas. Yeah, same. Definitely the answer is bananas. Obviously.
I mean,
Chemical
y'all
engineers-
laugh, but bananas are pretty relevant to nuclear engineering. They are slightly radioactive.
They are. I did not know that. That's kind of funny.
Yeah, it's the potassium that's inside of them. There's a
Ah.
radioactive isotope of potassium found naturally in bananas. It's not enough that it'll hurt you unless you eat like 600,000 bananas in like 5 minutes.
That's actually hilarious. I had no idea. Yes, chemical engineers use their specialized knowledge of chemistry to develop solutions. Physics, somebody chose bananas. Physics is used in more in mechanical and aerospace, and then electricity. I did bananas. Electricity is used in electrical and bananas. I don't know what to say about that except for that they're slightly radioactive. Yes, good choice. Gabby is in the lead. Aerospace and aeronautical engineers use their specialized knowledge of blank to develop solutions. Geology, bananas, electricity, or physics? Yes, it's physics. So geology is like about the earth and stuff. I think that's what civil engineers use to like not use, but like kind of know about when they're surveying the land and the water around them. And then electricity is electrical engineering. Physics is within aerospace and mechanical because aerospace branches off of mechanical. It's gonna be in some of the questions. Yeah, it's kind of it's definitely an answer in this one. Civil engineers use their specialized knowledge of blank to develop solutions. See, it's there again, but perfect. Bananas is in the yellow option. Now it matches the color. Civil engineers use specialized knowledge of blank to develop solution. Chemistry, bananas, electricity. Yes, physical and natural environments. They have to survey the land to be able to see if it's good enough for their physical and natural creation. Bananas rule. Well, why not? That's exactly it. Facts. Yeah, exactly. Gabby is still in the lead. Okay, final question. Mechanical engineers use their specialized knowledge of blank to develop solutions. Physics, electricity, bananas, or chemistry? Bananas is yellow again. Perfect spot for it. So mechanical engineers use specialized knowledge of physics to develop solution. Physics is a mixture of math and science, and it also talks about movement and stuff. So mechanical engineering does need physics. Again, electricity is electrical engineering. Somebody chose bananas. And then chemistry is chemical engineering. It was obviously bananas. Exactly. Okay, so let's see who got third place. Third place, we got Aziza. Everyone chose bananas. I can't because I cannot do the Kahoot. Oh no, you can do the Kahoot. Gabby got first place. Our runners up are Chris and Shelby. But congratulations, Gabby, for being in the lead. Okay, so there we go. Let me. Yes, good game, guys. Okay, now that we've done the Kahoot, let me pull something up. So what have we been doing here? What has been our goal for this camp? So our goal has been to have an introduction to engineering, to meet real female engineering role models, to get hands-on with engineering activities, and to explore and have fun. Have we done that? Yes, I think so. Let's put a check mark on that. Yep, there we go. We have, yes, we have. We've explored and had fun, done activities, gotten to meet many different role models, and we got an introduction to many different engineering fields. So that's great. So I'd like to congratulate you guys. You now officially know more about engineering than the average person, or more than like anyone in your age group. When I was your age, all I really knew about was STEM and like engineering. I didn't know any different fields of engineering. So this is really great that you guys know more than the average person, and now you're more ready than the average person at your age with getting an engineering job. We know more than average. I'm so glad to be here. I love this camp. I'm glad you guys have all loved this camp. I've loved it too. I've loved hosting it and hearing all of your comments and seeing all of your posts. So we're about to do an end of camp reflection really quickly. You also know more about engineering than the average adult who isn't in engineering. You know more about the average adult. Yahoo! Yes. So congratulations to you guys. Let's move on to our end of camp reflection. So either put it in the chat or write it in your workbook, however you feel, or do both. What type of engineering is the most interesting to you and why? And what problems would you like to solve in the future? That's my signature emoji too. So again, what type of engineering is the most interesting to you and why? And then what problem would you like to solve in the future? Thank you so much for hosting this camp. I've had a lot of fun in the past 5 days. Yes, I've had a lot of fun. This has been a really fun week. And throughout all the summer that I've been creating this camp, it was all worth it for this week. I now feel smart. Me too. I've learned a lot throughout this project. I really like civil engineering. I had a lot of fun this week. I'm glad you like civil engineering. Oh, a lot of them are popping up. I think the most interesting type of engineering is electrical because I think it sounds really fun to basically create a computer mind. Yes, artificial intelligence. Chemical engineering is the best for me. I love it. Chemical engineering because I like chemical reactions. Mechanical because I love building things. And electrical. So Shelby likes chemical and electrical. Thanks for this camp. I feel like mega mind. Okay, so any engineering at all sounds interesting. Well, yeah, again, you don't need to know what you want to be because there's going to be there's going to be a class you take in college, or like you'll have time to figure it out. I would like to help build flying cars. That would be very interesting. You should go for it. Definitely. Flying cars. Yes. So if you don't know which engineering you like the best, again, it's totally fine. This campus should just give you an introduction, not help you know what you want to be when you grow up. It's to give you options, give you information for those options, and give you role models to look up to for those options. Shelby also says she likes laser shows. Oh, that goes with electrical. Yeah. I would like to make a robot that takes care of children. So I think I would like to do electrical engineering. Well, it's more of mechanical engineering for robotics because it's a bunch of mechanisms that go together. But electrical engineers may help to program those robots, I think. Pretty sure about that. Everybody finished with their little reflection. Raise your hand if you'd like to stay here for a minute more or so. Or like if you're not done yet. Okay, yeah, we've got a few more people that are not finished yet. Then mechanical and electrical. Yeah, it's like a mixture of the two for robotics. And then when you're ready to move on, you can lower your hand. Okay, we got one hand left. For me, what type of engineering is the most interesting to you? It's chemical engineering because I really love chemical reactions and like experimenting with them, seeing what comes out from them, and then what problems would you like to solve in the future. I really don't know. I come up with a lot of stuff, but then I forget it a day later because of my I have really bad memory. So I mean, I just like to solve problems in the future. Someone says, I want to help find common problems using chemical reactions to create solutions. Yeah, we're in the same boat. Okay, still got that one hand up. So when that lowers, we'll move on to the next thing. Anybody else want to tell us what they're, okay, so we got two people, one hand up still. I want to help humans and animals decrease pollution. That's a really good problem to solve. Oh, everybody really quickly, Emily has to leave, our chemical engineer has to leave, so thank her in the chat really quickly. Oh, someone says I would like to solve cancer since my grandma had cancer. Yes, that is in the making of trying to find solutions for cancer. It's always a problem that needs to be solved. So I feel like that's a great problem to want to solve. Again, thank you, Emily. Okay, now she's left. Oh, so sad. I wish this wasn't the last day of camp. I wish there were more days to come. But again, you guys don't have to stop posting in the Facebook group. If you ever find a fun activity, or if you ever do your challenges again in the future, like in a STEM themed birthday party or anything, or just a hangout with doing the STEM activities, you can always post on the page. Okay, the hands are all down, so we can move on to the next thing. So like we did at the beginning of the week, we're gonna have you do it again to see if it's changed. what does an engineer look like now? Draw one below. And if you guys want to, you can post them on the Facebook group. I'd really love it if you could, so I can make a little montage to show all your engineers that you drew. Thank you so much for this camp. Thank you for attending my camp. It's been really fun with all of you guys. Getting to know you through the comment section. I loved it so much. I loved it so much too. I've had so much fun creating this camp, hosting this camp, seeing all the challenges you post. I've loved every single part of it, the entire journey. This was so fun. Same. Yeah. So I'll give you a minute or so to finish your drawings. Finish that quickly because then we're going to do a poll right after it that has to do with it. So raise your hand if you're not finished drawing, and then lower it when you're finished drawing it. Everyone here is so nice. Yeah, everyone here has had really good positive energy in the chat. I'm glad none of you have had any issues throughout the week with your challenges or activities, because yeah, because not a lot of you have come to the help desk, but that's a good thing because you guys have been experimenting and trying things out on your own. This was the best camp ever. Love it. Also, by the way, at the end of camp, have your parents keep checking their emails, because we're going to have you guys do a survey when camp is over. Just kind of asking you questions about how it went, anything you changed. It's kind of long, but I mean, all the questions are relevant. Thank you so much. I love hot glue. I'm glad you love hot glue. Though you had a little bit of a few burns, one on your leg and one on your finger or something. Oh, Mara G, she said, I drew you and me. Aw, you guys are so sweet. Okay, so are we finished drawing our engineers? I think we are. So I'll just pull up the poll now so you can fill it out as you go, because I think you figured this out already. Okay. Did you draw a boy or a girl engineer? I drew a boy or I drew a girl. I got burned once and it's fine. I drew both. Oh, I mean, hey, at least what do I put? Just put I drew a girl. Okay, 3 more people to go. I got burnt too. Oh no. Well, at least you're not scarred from your experience. Great job, Ruby. Congratulations on doing your goal. Thank you, Miss Jean. Yeah, I've learned a lot through this entire gold award process. It's been a lot of learning moments. Okay, so my mom said this to my dad. Why didn't you tell me that this hot glue gun was existed? Okay, so I'll end it here. Okay, bye, Miss Jean. Okay, so here's the results. You guys all drew girls, or at least included a girl in your picture. My mom can't live without it. So yeah, congratulations, guys. We have beat the stereotype throughout this week. Congrats. I can see it now. Might burn myself. I still have fun. Yeah. So congratulations. We've been beating the stereotype throughout the week. It's not, we've done that. We did the live poll. So we've been going throughout the week with this future women engineer promise. Can you guys see it? Just making sure that you do before I move on. Yeah. Okay, cool. So throughout the week, well, except for Monday, I think we added this in on Tuesday, but throughout the week, we've been going over one step at a time of this future woman engineer promise. But it's just kind of a cute little thing to go over at the end to remember to stick with it and keep going. Think like an engineer, ask like an engineer, act like an engineer. What is it? So here, let me 1 second. Oh no. Can you spotlight me? Oh, yeah. It's like I'm trying to spotlight myself. So along with me, raise your virtual hands really quickly. Raise your virtual hands with me to do this promise. It's got 7 of you. 8, 9. 6 more to go. 10, 11. 4 more. If you're unable to, just let me know. But raise your virtual hands along with me to do this promise. This is funny. Yeah, I mean, we're not in person, so we'll raise our virtual hands. Okay, so I promise to pay attention in math class and science. I promise to raise my hand when I have a question. I promise to look for problems and create solutions. I promise to build things and improve them. I promise to spread the word to inspire more future women engineers. I promise to check out more STEM activities on the engineering website. It's to be announced. I'm still working on it, but it'll be out very soon, and I'll put a bunch more different activities that you guys can do. And stay in the Facebook group, because with those extra activities I'll be putting in the website, you can put them on the Facebook group. So yeah, don't forget to keep posting. You can post as long as you want. Bananas, nice. So yeah, here's the engineering promise. It's in your book. You can check it out whenever you want. But yeah, remember to act, think, be like an engineer, and spread the word. You can share this website with anyone you want. Do it with friends. Have a STEM themed party, or a chemical engineering themed party, or anything themed party with all these stuff. But the website will have everything included in it that we had in the camp, plus parent and camper resources. Yeesh, the banana rules. Minions love bananas. We're still going on about bananas. Didn't know it'd be this big of a trend. But another thing, special thanks to all the professional engineers and college students studying engineering, and all the teens supporting my Gold Award. And did you notice they were all female? And to all the campers, current and future, who attend my EveryGirl engineering camp. If it wasn't for you guys, this camp wouldn't exist. If it wasn't for, yeah, I'm very thankful for you guys joining my camp, for the adults who have done the Q&A today, and the teens who have helped with the activities, and for the campers for coming, and for the college students for giving us the college experience Q&A sessions each day. Thank you to all of you for helping me with my project. But another thing, next slide. You're all invited to the launch of our EveryGirl engineering website. We couldn't have made it without you. You will find lots of parent and girl resources to keep this STEM party going. Watch for an email and a Facebook posting when the website is launched. And bye. This sucks. I don't want the camp to be over, but it's day 5. I'm so grateful that you guys have been a part of this experience with me. It's been fun. So I'll let you guys say bye in the chat really quick, and then I'll end off the meeting. Oh. This has been a great experience. I'm crying. Oh. Oh God. Thank you guys for coming. I'm gonna end it now. But keep posting on the Facebook group. Thank you for this experience. I'm gonna end it now. Thank you so much.